Okay, number one, what is the conjugate of these things? The conjugate just means you take the middle sign and you change it. So the conjugate on the first one is -2 plus 2 square roots of 7. The conjugate of the second one is -1 minus 3 square roots of 5. That's all you do is you just change the sign in the middle. That's all you do. Simplify. So we've got a square root here. So simplifying means making a factor tree for 18. So you can do 2 and 9, 3 and 3, or you could do 6 and 3 and then change to 6. But we're looking for a square root for a pair of numbers. So 3 is going to go on the outside with the 7. We're also going to have some letters on the outside, so I'm going to skip a spot and then put my square root because 2 needs to go on the inside because it didn't have a pair. I don't do anything with the 9 because it split off. I only look at the bottom of the tree. Now, m cubed, remember that's m times m times m, so I have a pair of m's, so I write m on the outside. I have an m left over, so that goes on the inside. The same exact thing would happen with n cubed, right? So I'd have an n on the outside and an n on the inside. And then I just need to rewrite this as 21. So, I mean, technically you could erase 7 times 3 if you wanted to be lazy. Not like a bad kind of lazy, just a lazy kind of lazy. Factor tree for 40. 4 and 10. 2 and 2. 2 and 5. All right, so we have to look for sets of 3 instead of sets of 2. So that's 3 2s. That's 2 on the outside. There's a 5 left for the inside. Then we have to look at our x, y's, and z's. So x to the 5th, how many sets of 3 do we have in x to the 5th? We just have 1 with an x squared left over. How many cubes do we have in y to the 8th? Well, we've got 2 of them with 2 left over. And how many times do we have sets of 3 for z to the 6th? 2 with none left over. And so, and I kind of wrote that badly because of my space. 2x squared. No, the x isn't what's squared. 2x. So make sure you're clear when you write this. 2x, y squared, z squared, the cubed root of 5x squared, y squared. There's no z's left to put inside. Yeah, and make sure you put cubed root because it doesn't change from being a cubed root. Okay, 36m to the 6th to the 1/2 power. There's more than one way to do this. If you ask me, the easiest way is to switch this to a radical right away. The top is the power, the bottom is the root. So we're talking about the square root, since it's a 2, of 36m to the 6th, which is to the first power. Okay? So the 2 on bottom tells us it's a square root, which we don't normally put the 2 there. The power is 1, and so we put 36m to the 6th to the first power. Now that first power isn't going to make a difference because it's just to the first power. So we need to simplify the square root of 36m to the 6th. So the square root of 36 actually works out to be 6, or we can make a factor tree to figure that out. The square root of m to the 6th, we look for how many pairs of m's do I have if I have 6 of them. I have 3 pairs with none left over. So my square root goes away completely, and my answer is 6m cubed. All right, so 8n cubed to the 5/3. So the biggest thing on these problems, and it's not just on these, there's some other ones like this, you're going to have to remember the powers on top, the roots on bottom. So this is the cubed root of 8n cubed to the 5th power. The easiest way to do this is to do the cubed root part first. So ignore the 5th power. Let's do the cubed root of 8, which you can make a factor tree, or if you know it, that's fine too. We have 3 2s, so that's 2 on the outside. The cubed root of n cubed, well, I have 3 n's, so that's an n. Now we're going to bring back the 5th power. Okay, so we did the cube root of 8n cubed. Now if we do the 5th power, we have to do 2 to the 5th power and n to the 5th power. The n isn't the only one that gets the exponent. Both of them do. 2 to the 5th power, you can type into your calculator. It's 32, yeah. So 32 n to the 5th is our answer. Now, on both of those, like I said, you can do them differently and still get the right answer. I'm just telling you that is the way I think it's the easiest to do. Like we could do the 5th power first and then do the cube root, but then we have bigger numbers. So it just makes it seem more difficult. Questions on 4 and 5? You can do 8 to the 5/3, and it will tell you that that's 32. And then you'd have to do n to the 3rd, and you'd multiply the exponents together and get 5, and that works. So it just depends on which way you want to do it. Number 6, we want to distribute the square root inside the parentheses and simplify as needed. So square root of 2 times 5 is 5 square roots of 2. Square root of 2 times square root of 2 is square root of 4, which I just wrote a 5 for no good reason. It's square root of 4. So now we simplify. 5 square roots of 2 doesn't simplify because it's just the square root of 2. The square root of 4 is 2, so we can change it and just make it be minus 2. On 7, we are subtracting 2 square roots, which we're only allowed to do if they're the same square root. So we're going to start off by simplifying both of these. And if we're lucky, unlucky, depending on your perspective, we'll be able to have the same square root and be able to add them together. Okay, so I am looking for pairs of numbers because it's a square root. So I've got a pair of 2's and another pair of 2's and then a 2 left over. So outside my parentheses, I already had -2, not parentheses, square root. I had a -2. I'm going to put 2 more 2's for my pairs, and on the inside goes the last 2. Okay, so this -2 is right here. Then I was simplifying. Okay, now we're going to do the square root of 18. So it's going to have that -2 in front. We're going to make our factor tree. I have a pair of 3's with a 2 left over. So it's going to put a 3 on the outside and a 2 on the inside. So I need to multiply this out. That's -8 square roots of 2. I need to multiply this. That's -6 square roots of 2. So do I have like square roots now? So I can just add the numbers in front. -8 plus -6 is -14 square roots of 2. The square root doesn't change whenever we add square roots together because it's the same as like -8x minus 6x is -14x. Okay. Number 8, we've got 2 terms and 2 terms, so this is going to require us to FOIL. Square root of 2 times negative square root of 2 is negative square root of 4. Square root of 2 times 3 is 3 square roots of 2. -4 times negative square root of 2 is positive 4 square roots of 2. And -4 times 3 is -12. So that's foiling. Remember, you only multiply stuff that's inside square roots together or stuff that's outside. So that's why we have 3 square roots of 2 and not like some square root of 6 or something crazy like that. The square root of 4 is -2. So I can change this to -2. Sorry, the square root of 4 is 2 and it was negative. So that's -2. So I can add like terms. -2 and -12 add together to get -14. 3 square roots of 2 plus 4 square roots of 2 is 7 square roots of 2. So here's my answer for that. Number 9 is actually the same type of problem, but you have to remember that you write it twice so that you can FOIL. You can't just square both of the things in parentheses, call it good, Okay, because what we're really saying is negative 1 plus the square root of 3 times negative 1 plus the square root of 3, which means FOIL. So negative 1 times negative 1 is 1. Negative 1 times square root of 3 is negative square root of 3. Square root of 3 times negative 1 is negative square root of 3 again. Square root of 3 times square root of 3 is square root of 9. Okay, now we're going to simplify anything we can. Square roots of 3, those don't simplify, but the square root of 9 is 3. So I can add like terms. 1 and 3 add up to be 4. Negative 1 square roots of 3 minus another 1 square roots of 3 is negative 2 square roots of 3. Make sure you're careful on stuff like that. They don't cancel each other out. You have to add them together to get negative 2 square roots of 3. All right, so the object when we are doing this is that at the end, we don't want a square root on the bottom. If you will simplify the square roots together first like a fraction, so tell me, what is 6 over 32 if I reduce it like a normal fraction? 3/16. So what we can do is we can say this is 4 square roots of 3 over the square root of 16. Okay? Because we're just taking 6 over 32 and we're simplifying it by dividing them both by 2. Now, I know the square root of 16 is 4, so I can change square root of 16 to 4. I can make a factor tree and figure that out as well. The square root of 3 doesn't simplify because it's just 3 times 1. And so now I can cancel out on the outside of my square root. 4 over 4 is just 1. So my answer to this is the square root of 3. So if you can simplify this as a fraction, that's the way you want to start. It'll make it easier in the long run. If you can't, or if you don't remember to do that, to get the square root off the bottom, like on 11, you need to multiply by the square root that's on bottom, on the top and bottom. Okay, so the square root of 2, we multiply on the top and the bottom. If you wanted to, you could multiply by 2 square roots of 2, and it would still end up giving you the same answer. But the easiest thing is just to do the square root of 2. So on bottom, 2 square roots of 2 times the square root of 2 gives us 2 square roots of 4, which we'll be able to simplify. On top, we do the square roots together, so that's 3 square roots of 6. So the square root of 4 on bottom we can do, that's 2. So that's 2 times 2, because we already had a 2, and that's 2. So this ends up being 3 square roots of 6 over 4. All right, so 12, we're going to do what we just did. We need to multiply the top and the bottom by the square root of 7 to get the square root off of the bottom. But on top, that means we're going to have to distribute. So 5 times the square root of 7 is 5 square roots of 7. Square root of 5 times square root of 7 is the square root of 35. That's the top. And neither of these square roots simplify, so the top is probably going to stay what it is. On the bottom, I have square root of 7 times the square root of 7, which is square root of 49. And there's a 2 in front of it. But square root of 49 is the same as 7. So I need to do 2 times 7 on the bottom, which gives me 14. If you get an answer like this and your answer is not on there, like on the answer choices, you might check to see if there's a number that will divide into what's in front of each square root in the bottom. Okay, like if this was like a 10 and a 2 and a 14, well, I can divide all of those by 2 and I can simplify. Okay, this one doesn't because we have 5, 1, and 14, and nothing divides into 1 except 1. Number 13 has to do with that conjugate thing on on number 1, because what we need to do is multiply by the conjugate of 4 plus the square root of 5, which is 4 minus the square root of 5. But we have to do it to the top and the bottom. On top, the 2 distributes. 2 times 4 is 8. 2 times negative square root of 5 is negative 2 square roots of 5. This is the answer to 12. Okay, 8 minus 2 square roots of 5 is on top. On bottom, we have to FOIL, except because we're trying to get the square root off the bottom, the outer and inner term will cancel out. So instead of having to FOIL, we really just have to FLA, because we just have to do the F and the L. Okay, so if you don't remember that, just FOIL it out and the middle terms will cancel and you'll be fine. But if you remember, then it's shorter. 4 times 4 is 16. Square root of 5 times negative square root of 5 is negative square root of 25, which is 5. So on bottom, we can do 16 minus 5, which is 11. On top, we still have 8 minus 2 square roots of 5. And again, if all 3 of these numbers that I have that are in square roots, if those will simplify, all 3 of them, then you would do that. If only 2 of them will simplify, you can't do anything. Okay, so perform the indicated operation on 14 through something or another. We're going to multiply because it says g times h of x. So I want to take g and h and multiply them together. And this does not mean multiply by x. It just means that at the end, I'm going to have my answer with x in it. So if I'm multiplying these together, I need to FOIL. 4x times x is 4x squared. 4x times negative 4 is negative 16x. Negative 5 times x is negative 5x. Negative 5 times negative 4 is positive 20. The middle terms will add together. So we add them together. Negative 16x minus 5x is negative 21x. So this is our answer. Like I said, this x does not mean multiply by x. It means there's going to be an x in my answer. Because sometimes they'll put a number here, which means we'd plug in a number and get just a number as our answer. 15, f of x minus g of x. So this is f of x. I'm going to subtract g of x, which means that I need to change all of the signs for g. Okay, because if I'm subtracting all of this, that means every single one of my signs is going to change. So I'm going to have minus x squared, minus 2, and minus 2x. And then I add like terms. So if you want to put it in standard form, x squared should go first, so that's negative x squared. Then my x's, which actually cancel each other out. And then negative 3 minus 2, which is negative 5. So my answer is negative x squared minus 5. This dot that's open does not mean multiplication. It means that we are going to take h of x and we are going to plug it into g. So h of x is x minus 3. I'm going to put it where the x is in g. So that means I have x minus 3 squared plus 5. So I need to simplify this. So I need to actually do x minus 3 squared, which means I have to FOIL x minus 3 times x minus 3. So I get x squared minus 3x minus 3x plus 9. And I've still got that plus 5 the whole time. And then I can add like terms. The x's will add together. The numbers will add together. So I have x squared minus 6x plus 14. Okay, 17. You think of this backwards, okay? The 5 is going to go into f, and we're going to get our answer. And then whatever answer we get, we're going to plug into g. So if I plug in a 5 into f, that means I have 5 cubed plus 5 times 5, which is 125 plus 25, which is 150. That's what f of 5 is. I'm going to take my answer and I'm going to plug it in to g. So I'm saying, what is g of 150? 150 minus 1, which is 149. All right, 18 and 19 actually are asking us to do the same thing to figure out what x is. And so if we are trying to figure out what x is, that means to factor. Since there's a 5 in front here, we're going to slide and divide. So I move the 5 so that I have x squared minus 19x. I multiply 5 times -4 and get -20. I'm going to set up my two parentheses. I'm looking for what multiplies to get -20, that adds to get -19. So you might be like 4 and 5, no. 2 and 10, no. 1 and 20, yes. The 20 would be negative, the 1 would be positive. And then since we're doing slide and divide, we have to divide by what we slid earlier. We slid, now we divide. So divide both of them by 5. 20 divided by 5 is 4. I can't divide 1 divided by 5, so I move the 5 in front of the x. So now I set each part equal to 0 to finish solving. So x minus 4 equals 0, and 5x plus 1 equals 0. Add the 4 to both sides on this one, and you get x equals 4. Subtract 1. So I get 5x equals -1. Divide both sides by 5. X equals -1/5. Then I go up to my multiple choice and I say, which of those is the answer? 4 and -1/5, so D. And make sure you're being careful. If you stop here where you factored, you might be inclined to think it's -4 and +1/5, which isn't an answer choice on this one, but could be an answer choice just to throw you off. So be careful. All right, this one, if we factor, they all three have an x, so let's take out that x that they have in common, which gives us x squared minus 8x plus 15. And then we're going to factor again, because x squared minus 8x plus 15, I can split up into two parentheses with x's, where I'm looking for what multiplies to get 15 that adds to get -8. -5 and -3. So we're trying to find 0, so we set it equal to 0, which means x equals 0, x minus 5 equals 0, and x minus 3 equals 0. So my answers are 0, +5, and +3, because we have to add the 5 over and add the 3 over. So that's D. D as in Delaware. Write each expression in radical form. So remember, the top is our power, the bottom is our root, and so this is all we have to do is say this is the cubed root of 3p squared to the first power, or you don't even have to put the part with 3p squared to the first power. You can just put the cubed root of 3p squared. Okay, like either way. Okay, because the first power doesn't do anything. That's our answer. Yeah, and now we're going to go the other way. So notice that the fourth power here is only affecting the b because we don't have parentheses around 2b. So here we actually have 2b to the fourth is to the first power. So power over root means, because all we're trying to do is write it in exponential form, I have power over root, which gives me 1/3 on the outside. So the answer to this would be 2b to the fourth to the 1/3 power. So in this one, My root is 3, my power is 4, so this is just n to the 4/3. Easy peasy. It's not asking us to simplify, because we could simplify and say that that's n cubed roots of n. It wants us to write it in exponential form, which means you're going to take what's underneath your radical, which is n, and you're going to write it as with a rational exponent.
So you don't have to put parentheses around the end of the full.
Not if there's only one. If there's only one thing, you don't have to put parentheses. If there's more than one, you'd want to put parentheses. On 23, 7/3 doesn't simplify. So we're going to have 7/3 in our answer. Our x's, though, we're going to subtract their exponent. So we're going to do x to the 7/8 minus 3/8. And then we're going to do y to the 4/5 minus 1/5, because we're subtracting our exponents from the top to the bottom. So when you see fractions, you subtract the exponents. So either do that in your head, because these are actually pretty easy, or do it on the calculator. Remember, math enter, we'll change it back to a fraction for you. 7/8 minus 3/8 is 4/8. But 4/8 simplifies to be 1/2. So we should have x to the 1/2 power. 4/5 minus 1/5 is 3/5, which does not simplify. And the 3 is still on the bottom. So that's our answer, because we have just an x, just a y, and our numbers don't simplify. All right, if there aren't any fractions, as in like big fractions like this one, okay, then we take our normal numbers, we're going to multiply those together. 3 times 2 times 3, which is 18. And then our exponents add together. So x, we're going to do -1 plus 2/3 plus, what does this x have as an exponent? Since it doesn't have one, it's just 1. Then we're going to do the same thing with our y's. This y has an exponent of 1 plus 3/2 plus 1/2. Again, you can type it in the calculator and it'll tell you what your exponent should be. This should be 2/3, because the -1 and the 1 actually cancel each other out. This one should be 3, because 3/2 and 1/2 actually adds up to be 4/2, which is 2, and 2 plus 1 is 3. This is our answer. If there is a parentheses with an exponent on the outside, parentheses, exponent on the outside, we're going to give everything inside of our parentheses that power. So x doesn't have an exponent, so it's 1. Okay, so that means x is going to get the 1/2 power. If it already has an exponent like the y does, what we need to do is multiply 2/3 times 1/2 to figure out what that exponent should be. So the 2's will cancel, and we'll just get y to the 1/3. Or you can type it into your calculator and let your calculator handle the fractions for you. 26. We're going to multiply both of these exponents by 2. Okay, so 5/3 times 2/1 is 10/3. That doesn't simplify. 2/1 times 2/1 is 4/1, which is just 4. So that's x to the 10/3, y to the 4th. On 27 and 28, we are solving square root equations, and so we want to get the square root by itself on one side of the equation if possible, and then square both sides. So on 27, since there's a square root on each side, we just need to go ahead and square both sides. Okay, because the opposite of taking the square root is to square something. What it does is it gets rid of our square root on the left side and gives us 3k minus 12. And then on the right side, the square root and the squared cancel out, and it gives us 2k minus 5. Then we subtract to get our k's on one side. So I'm going to subtract 2k from both sides. So I get 1k, or just k, minus 12 equals -5. Then I add 12 to both sides. Oops, my line went a little crazy there. There we go. So k equals negative 5 plus 12, which is 7. And then it tells you, remember to check for extraneous solutions. That means extra solutions, so solutions that aren't really solutions. So what we want to do is figure out if I plug in 7 where k is at the top, do I actually get the same thing? This is 21 minus 12, which is 9. You square root that and you get 3. This is 2 times 7 minus 5, which is 14 minus 5, which is 9. Square root of 9 is 3 again. So they do equal each other, which means 7 really is a solution. Man, 7 really is a solution. And then we go on. On 28, we need to get the square root by itself to start off with, and so that means I'm going to add 4 to both sides of my equation. That gives me the square root of 2v plus 1 equals negative 1 plus 4, which is 3. Then, now that my radical is by itself on the left side, I'm going to square both sides to get rid of the square root. So that leaves me with what's under the square root, which is 2v plus 1, and 3 squared, which is 9. So I'm going to subtract 1 from both sides and get 2v equals 8. Then divide both sides by 2 and get v equals 4. We're going to go back and check our answer. So negative 4 plus the square root of 2 times 4 plus 1 should equal negative 1. So you can actually type this whole left side into your calculator and it'll tell you what the answer is. And it should be negative 4 plus 3, which is negative 1. So that means that that this really is an answer, since negative 1 equals negative 1. 29, we want to get the power part by itself. Like, this is a parentheses to the 1/4 power. So that's good. We want to raise each side of our equation to the reciprocal power. This is 1 over 4, so we're going to raise each side to the 4 over 1. So 2 to the 4 over 1 is 2 to the 4th, which is 16. You can type that in your calculator if you need to. On the right side, the whole point of this is to cancel out our power. So 1 over 4 times 4 over 1 is 1, leaving us with just 7 minus k. I'm going to subtract 7 on both sides and get 9 equals negative k, but I don't want negative k, I want regular k. So I divide both sides by a negative 1 and get negative 9 equals k. Now, on this one, what I want to get by itself is this n to the 3/2, because that's the only part of that that's to a power. So before I flip my power or anything, I need to add 2 and also divide by the negative 3 that's in front of n. Negative 2,189 plus 2 is negative 2,187. Now we divide both sides by negative 3. We get n to the 3/2 equals 729. Now we're going to raise each side to the reciprocal power. So the reciprocal of 3/2 means we do 2/3. So it cancels out the power on the left and gives us n. 729 to the 2/3. You can type into your calculator. You just type 729. You use that exponent, and if your calculator might put it as an exponent, which means you would just put in 2 divided by 3. If it puts in the symbol where you're typing, then you need to put this in parentheses, this 2 divided by 3. And you should get 49. It doesn't say to check for extraneous solutions, and I'm pretty sure that these won't ever have, or these shouldn't have, extraneous solutions. So you don't have to check your answer if you don't want to, but if you do go back and check your answer, then that's helpful because that means you know you got it right. So that's all.